two equal spheres of mass 10 tac 4-4. I'm going to assume it's 10 to the negative 4 kilograms each, and equally loaded, are suspended from the same point by 13 centimeter long silk. It says silk, what that means is it's an insulator. Basically, it's not conductor. 0.1 meters is separated by the effect of repulsion, so the distance between Q1 and Q2 is 0.1 meters. It's interesting that they use meters here, but then centimeters there. They could have said like 10 centimeters. That's okay. We'll go with this. Calculate the charge of each of the spheres. Okay, so we want to find the charge. So start here with a free body diagram. So this is going to be tension. This will be force due to gravity, and this is going to be force electric. I know they're supposed to be arrows. They're kind of dull. I should sharpen my arrows. Okay, so this is going to be tension in the x direction, and this is going to be tension in the y direction. I just broke down the tension into its x and y components. So now we're going to be able to say that the force electric and force gravity correspond to the y and x components of the tension. So let's see here real quick. Draw these a little bit bigger. So we know that this whole thing right here is 0.1 meters. So this right here is going to be 0.05 meters, half of 0.1. This is going to be 0.13 meters. And we have some angle theta there. We don't really care about that angle. We care that it is the same as that one. And we could find that angle using these and SOHCAHTOA. Okay, so we're going to start with the x direction. And we know that, let's see here. If this is tension, we can say that, and this is, we'll do SOHCAHTOA. So we know that tension in the x direction, tension x, is going to be force electric, equal to the force electric. So, yes. So tension x, which is going to be tension times, that's going to be SOHCAHTOA, so sine of theta equals opposite over hypotenuse. We want the opposite, so opposite equals sine of theta times hypotenuse. There we go. So tension x, which is opposite, is the hypotenuse, which is tension, times sine of theta. And we could go for that. Yes, we're going to go for that. Okay, so now tension x is going to be equal to force electric. So the force electric is going to be K Q1 Q2 over R squared. Whoop. Get rid of some of this. Get rid of some of that. Where we know the distance in this case is going to be that distance, 0.1. So this, and then Q1 equals Q2. So Q1 equals Q2, which is a mystery charge. So this is going to be, and K is 8.99 times 10 to the 9th, but I'm going to round that up to 9. So we're going to have 9 times 10 to the 9th, Q squared, all over 0.1 squared. Okay. And then, do I want to find theta? I might want to find theta. We'll worry about that later. Okay, so this is one equation. Now we want another equation for the y direction. And we're going to use gravity. So this time, we're going to say that tension in the y direction, which will be T cosine of theta, same concept earlier with SOHCAHTOA, and that's going to be equal to mass times gravity, which in this case is going to be 10 to the negative 4th kilograms times, I'll do 9.8. It would be convenient if I just rounded it up to 10, but I'm not that bold today. Okay, so now we can solve for tension on both of these and set them equal to each other. So we're going to do that. So tension, which equals 1 over sine of theta times 9 times 10 to the 9th times q squared all over 0.1. 0.1 I'm going to call as 10 to the negative first squared. Yes. Equals, now I'm going to use this equation down here, which equals t, which is equal to 10 to the negative fourth times 9.8 all over cosine of theta. So now, if you look at this, we have an equation right here with the q being the only unknown, and we have this equation over here. I guess we have theta, but we'll work with that later. So, rearranging this and solving for q, we're going to have q squared. I know there's going to be a lot of algebra in just one step, so follow along best you can. But so this is going to be 10 to the negative 2. This will be 10 to the negative fourth times 9.8 times 10 to the negative second. So I'm just moving that up. All over 9 times 10 to the 9th. And then we have a sine of theta over cosine of theta. Do a little bit of simplifying here. So this is going to be, when these combine, it's going to be 10 to the negative 6. 10 to the negative 6. This 10 to the 9th on the bottom is going to be 10 to the negative 9th on top. And then we're going to have 9.8 over 9 times tangent of theta. Okay? And now we can kind of go back and find our tangent of theta. So tangent of theta, SOHCAHTOA, opposite over adjacent. So opposite is going to be, let's see here. I might actually have to use my calculator. So opposite is going to be 0.05, and adjacent is going to be that right there, which is going to be 0.13 squared minus, because a squared plus b squared equals c squared. So this is Pythagorean theorem, minus 0.05 squared square rooted. So it's going to be 0.13 squared minus 0.05 squared square rooted. I know, kind of a funny angle. Move that over there. Grab the calculator. So, clear. 0.13 squared minus 0.05 squared. Second square root, second answer. Is this a... it's so convenient. So this, because it's a 5, 12, 13, it's just going to be 0.12 meters. So very convenient. So this is going to be 0.05 over 0.12. So simplifying this equation one more time. Hopefully this will be the last one. Let's go with red. So now we'll say that this is, that's supposed to be positive 9. No, is it negative 9? That seems like an awfully small number. Maybe it is. Maybe it is. Maybe it is. Okay, we're going to go for it. So this would be 10 to the negative 15 times 9.8 over 9 times, and then we decided it was 0.05 divided by 0.12. 0.05 divided by 0.12. Yep, this makes sense because it's q squared. Therefore, when we work this out, we have 0.05 divided by 0.12 times 9.8 divided by 9, and we have 0.4537, 0.4537 times 10 to the negative 15. Therefore, when we square root that, so times 10 to the negative 15, very small number, yep. Second square root, second answer, and we get 2.13 times 10 to the negative 8. 2.13 times 10 to the negative 8 coulombs. Excellent. Yes. So that seems very reasonable. So to backtrack kind of what we did here, we have the force electric pushing these apart, we have force gravity pulling it down, and we have a tension in this string. And since it's symmetrical on both sides, we can kind of use that along with trigonometry to set the x components equal to each other. We said tension of the string in the x direction was equal to force electric. We said the tension in the y direction was equal to gravity. We did some algebra to solve for tension along with trigonometry. And when we put it all together, we eventually found that Q squared was our lone unknown. Solving for that, we found Q is 21.3 nanocoulombs, which is possible. Very reasonable. All right, hope that helped. See you next time.